Hi everyone, and welcome to this May edition of our monthly meetups organized by CLIQ-ai, the consortium, the Computational Linguistics in Quebec consortium. As I said earlier, my name is Philippe Racine. I'm going to be your host. I'm a programmer specialized in NLP who works at the University of Montreal and for Ivado. So today, we have two engaging talks under the theme of NLP approaches for the domain of human resources. Last month, we discussed cyber justice, and this month it's human resources. First, Upul Bandara of the company Airudi will share the experience of the company in designing NLP-enabled applications for occupational health and safety, which is the domain of human resources. Then Philippe Racine, who is the founder of Stent AI and co-founder of V3 Stent AI, will show how AI can help the hiring process. So just before I start, I'm going to ask everyone to mute yourselves, except the presenter, obviously, so that we can enjoy the presentations without any background noise. So every talk is going to be followed by a 5 to 10 minute Q&A session. So you can write your question and ask them at the end. But for clarification questions, you can ask them during the talk. Just type them in the chat and they're going to be relayed to our presenter. So we're going to move on now to the first presentation. Upul Bandara, who's going to present Building Production-Ready NLP System, a case study of applying machine learning to occupational health and safety. So Upul, I'm going to present you, and all the while, maybe you could share your screen presentation.
Yeah, sure.
So Upul Bandara is a machine learning architect who has several years of professional experience in machine learning systems, data preprocessing, and large-scale software systems. At Airudi, his company, he's the technical leader for machine learning systems in the context of human resources. He previously worked at Imagia, the Montreal-based company, where he contributed to Imagia's federated learning system, a hot topic. So, Upul, whenever you're ready, the floor is yours.
Yeah, thank you. Thank you for the invitation. And so let me start my presentation. So today, so by the way, can you guys hear me? Is it
It's
loud
perfect.
and clear? Okay, so thank you. So today we're going to talk about a building production ready NLP system. So we use occupational health and safety as a kind of case study. So before moving to the actual presentation, so let me quickly introduce our company, that is Airudi. So basically Airudi is a kind of a HR tech company. So we use machine learning as well as human intelligence to build a machine learning enabled, maybe ABI, AI enabled product and services for the HR domain. And in our team, it consists of software engineers, then machine learning engineers, and then bunch of HR experts. So with the help of these awesome people, so we build a design, build, and then deploy machine learning enabled product and services for the HR domain. So today's presentation is mainly focused on our new service that is a kind of a chatbot. So we are in process of engaging the Quebec company that is mainly focused on workplace health and safety. Until recently, they use a manual method for reporting accidents and also getting accident prevention recommendation. So we in this partnership, so basically we designed, implemented, and recently deploy a chatbot that automate this manual process and also providing accident prevention recommendation. So in the next slide, I guess in the next, sorry. Yeah, I'm sorry. Yeah, so at high level, so this chatbot is so since we are Quebec company, So we use both French and English, so the chatbot can speak both French and English. I think that is good. And so at high level, so we use accident description that normally HR person enter into the system, and we look at this accident description and then find out high level accident category. What is the high level accident category that is associated with this given accident description? And also we look at high level risk, what is the risk that is associated with this given accident description, and also like a bit of a little bit more information. So like in our database, we have the mapping with accident description, high level accident category and accident risk, so with the sort of set of like preventive recommendations. So once we locate the accident category and the risk, so we can pull up those preventive recommendation, and then send we can send those things into our front end, and then front end will deliver to the HR professional. So at high level, this is the idea. So here, so you can see the main, or I would say like key component of our system. Like the first thing is front end, that mainly HR professional are like dealing with the front end. So that is a sort of like JavaScript based system. And the second one is the more important one here is the backend, chatbot backend. So this is a kind of like Python chatbot engine. So we design on top of the Microsoft chat building framework. So here, so you might notice two machine learning components. So rest of the presentation actually mainly focus on these two components. And also, like before going to the next slide, I would like to sort of like highlight, maybe quickly highlight two components that are also like key part of our ecosystem, like the chatbot cache. So that contains the chat dialogues that will load dynamically depending on the context from the Redis cache to the chatbot backend. And also finally we save all the interaction that so HR professional are going to made with sort of like the chatbot front end. So in our Redis, in our like Azure database, that basically contains all kind of like interaction that we are going to use when we retrain the machine learning model, and also like improve the user experience. Okay, so moving to the next part here. So I'm sure displaying something like that chatbot screen. The first one, this is the very first front end screen that the user sees. So basically here you need to pick up the like what type of accident has happened, whether it is some kind of like injury, so no, like one sort of like one person injured, or like a bunch of people injured, or maybe some death. So that kind of like high level description, so user have to pick it here. And then so we will move to the next section, where basically the user need to enter like an accident description along with some other relevant details. So we use those things, and under the hood our machine learning models basically utilize this information in order to come up with high level accident category as well as like accident description. Once we know these things, like, so we can clarify that the predicted outcome with the user. Maybe like we can ask the user, so are you okay with this high level accident category? If like he sees like this is okay, then he can go ahead. Otherwise, basically we list a bunch of like highly probable accident categories, and then ask user to pick one of them, and then we continue. So likewise, so the high layer idea is like we picked accident, we basically input accident description, and then we predict accident category and the risk category, and in the final part of the process, like, so we can send the most suitable accident preventive action to the end user. That is a high level goal of that chatbot. So let me move to the next. So here basically I highlight that the contribution of natural language processing in our chatbot. For example, this box, this component, and these components, they are mainly like NLP components, so basically text categorization machine learning model. So I'm going to give you a little bit more information so in the next couple of sections. So as I mentioned, like we train two machine learning models. One is that accident classification model. So here I'm going to give you like a very high level overview of what sort of like a model we are using at the moment, and a little bit more information about the data set. First, let me start with the data set. So right now, like we in our training data set, we have like 150 plus accident categories. And also the key point here is like, so like for each category we have like on average 5 to 10 accident description. That means like we are working on the low data regime, so we don't have like a lot of data to train our model. So that's why like we pick a transformer, and so we thought about like we need to like fine tune this transformer using our data set. So that is a very high level idea of like building our accident classification model. So here you can see kind of like block diagram. So what we did was basically we removed that the last layer of the distilled model, and then add one extra like dense layer, and then the softmax layer. This softmax layer contains like 150 like 150 plus output units, so that will predict the most probable accident categories. So when it comes to like implementation part of that the model, so we use that that Hugging Face Keras implementations distilled, and we fine tune our model on our own like a GPU server, which comes with a kind of like two GPUs. So I'm going to give you a bit more details when we move to that ML ops part of the presentation. So before moving to the next machine learning model, so I would briefly like to highlight key issues, or maybe like key challenges that we face while we are training our model. The first thing is like the limited amount of data. So as I mentioned, like so we have like 5 to 10 training examples per category. So I think by regarding that one and the number of categories, that is 150 plus. So I would say like, so we are working in the low data regime. And the other thing like a label ambiguity. So we notice that some of the accident description are labeled with more than one accident category label, even though this is not a multi-class multi-label classification model. And also sometimes we notice some accident description which doesn't contain enough semantic information that we can use to train our machine learning model. So next I would like to briefly mention few things that we were working on related to fixing those issues. And the first thing like, so we use a little bit of data augmentation. So like right now this is a kind of like very simple data augmentation techniques like synonym replacement and swapping words and random deleting, so that kind of thing. But so we have started another sort of like initiative. So what we are planning to do is like use some of the sort of like state of the art techniques to generative models to generate some text, so that looks like our that training examples, and then maybe increase our sort of like training amount of training example. Also we did a lot of manual error analysis and then find out some issues and fix them. And also we did a label correction with the help of SME. So we have like in-house SME. She is really good at the HR related matters and accident prevention. So we took that advantage and like do a lot of label corrections there. So next I would briefly like to discuss the risk classification model. So as you notice, like this is also kind of like similar to the previous one, but in this situation we have like 450 plus label categories. And so when it comes like amount of the data points per category, it's kind of like on average 3 to 5. And here I extracted 2 training examples for you to get some kind of idea as what sort of like risk categories we are working on. For example, like fall to lower level and verbal aggression. These kind of things are like common risk categories that we can see in our training examples. So here I want to briefly highlight something that the model that we use to predict the risk level, so which is almost identical to the previous one, but instead of like accident description we use accident category as an input, and similar to the previous the machine learning models, we remove the dense layer, the last layer, and then add the extra dense layer and softmax layer, and then we use a sort of like a Hugging Face Keras implementation, and then fine tune the entire thing as a one model, and then do the predictions. So when it comes like issues, so we notice a same level of issues like a limited amount of data, label ambiguity, and then not enough semantic information in our training examples. So these things we fix a similar way as we discussed previously. So I think next we can go to like our ML ops systems, like what sort of like tools available in our system. So let me like briefly explain this part. So at very high level, so we can divide that our ML ops system into two subgroup or sub sections, like development section and the production section. So as you notice that ML flow server is a kind of like key component here. So that is shared by both the development section and the production section of our ML ops, and both the ML flow server and also like DVC, that is our like data versioning system. So like configured to work with the Azure Blob Storage. So under the hood, that means like all our training artifacts, machine learning models, and data, so we save securely in our blob storage. And if I move to the production section, so we use fast API in order to expose our machine learning model, and also so we use Docker containers to deploy the model, and Azure Cosmos DB. So as usual, save all the interaction, I mean like that accident description that comes with the post body, and the predictions we save everything in the Cosmos DB. So high level idea is so we are planning to use this information when we want to retrain the machine learning model. Okay, so next I want to briefly mention or go through that the path that normally data scientists use when it comes like building a machine learning model. So data scientists normally comes and then so look at or browse available data sets, the versions of the data sets, and then come up with a new machine learning model or something like that. So he trained the model and registered everything using the ML flow server, and so under the hood it sends those artifacts into blob storage, and it is secured in the blob storage. And so this is our training server. So we use like Lambda Labs GPU server with 2 GPUs. Right now it's like GTX 3090 GPUs. We share those GPUs among our data scientists. So when it comes to like exposing the model for the production, so as I mentioned, we use Docker container, and so we build the Docker images using our CI/CD pipeline. So I'm going to explain that part later. So so when we create the machine Docker image, so we tag that thing with the ML Pro run ID. So it contains all the information required when we want to grab the machine learning model and the relevant artifacts from the ML Pro server. And then as I mentioned previously, like when a new request comes, like we serve that thing, and then we save all the information, I mean like the data that comes with the post body, and also the prediction in our Cosmos DB that we are going to use for future training purposes. So here you can see a couple of snapshots of our ML Flow server. So right now, so this is a key component that we have in the server. Like we save all our experiment there. So anybody in the company can go there and then look at the progress of the training, as well as like how the training works, all the learning curves and some other artifacts also there. And in addition to that, as I mentioned, like we save the model itself in the MLflow server. So when it comes like production time, so what our machine learning engineers has to do is like grab the machine learning model and related other artifacts, maybe like some binary encoders and that kind of things directly from the MLflow server, and then so we can start deploying the machine learning model. So as I mentioned previously, this is our CI/CD pipeline. I would say like part of it that is related to like building the Docker image. So as you know, like in the ML flow, every machine learning experiment is identified with this unique ID, this hash. So what we are going to do when it comes like building the machine Docker image, we tag the Docker image with the correct machine learn ML flow ID. So that means like when we deploy this Docker image, so Docker container sort of like has access to this information, and it automatically grabs all the required information from the ML flow server and then start the serving process. So at high level, so this is the CI/CD pipeline, and up to now, so like a CI/CD pipeline and the ML flow components that we have so with our system. And up to this level, basically I discuss things that we implemented and deployed. But so after this one, like this one, and I use couple of slides to discuss some future directions related to machine learning model and then ML of systems and some other implementation details, some other that a component that are really need it, sort of like a machine model monitoring systems, and then AB if we need a sort of AB testing frameworks when we have like a couple of more that machine learning models we want to pick the best one automatically. So as you notice, so we have like a machine learning models, two machine learning models, but both of them are sort of identical. So we thought about like combine those things together and create one machine learning model. So the input is the input for this model is accident description, and also we have two outputs like predicted accident category and the predicted risk. So by combining these two things, we thought like so we can maybe like use the information and share the information between these two models that might help us to like the come up with a better accuracy and better stability. So at the moment, like the results are really promising, but I feel like we need a bit of more time to fine tune this thing before putting it into the production. So like we are working on this thing at the moment. And next I would like to highlight the key improvements that we are planning to implement on top of our MLOps system. Like so we are expecting like a lot of more customers in coming months, so we therefore like planning to implement this serving part on the like Kubernetes cluster. So very high level idea is like so we can auto scale our resources like depending on the workload. In addition to that here, so we are planning to implement the API gateway as well. The high level idea here is kind of like we can do monitoring, throttling and that kind of thing, metering and that kind of like a high level API related functionalities we are planning to implement there. So finally, I would like to sort of highlight that importance of a model monitoring system. As we discussed, like we are working with a very limited amount of data, so we don't know like how this machine learning model is going to work in the future, how the data distribution going to change, how the performance is going to change, and this kind of things. So we believe like we need a strong machine learning sort of like model monitoring system. So we started this process, but so our idea is like working on some tools, something like maybe like Prometheus or Grafana, that kind of things to implement uh, sort of really promising kind of model monitoring system. So these are the like high level things that I wanted to discuss. So we discussed related to like building a machine learning model and then putting it into the production, and also discuss how we can implement that part, how we can improve the current model using that model improvements and some improvement to our MLOps system, and then implementing some model monitoring part as well. I think that's all I have today. So yeah, thanks for your attention, and if you need any help, any questions, so I'm happy to answer now.
Thank you very much, Upul. It's
Thank you.
quite interesting and well done, well deployed within Airudi. I have a few clarification questions. So at the beginning, you started showing an example of the interaction with the chatbot. So I just want to get a clear sense of exactly what is done. So at the very beginning, uh, the user selects the kind of event that has occurred. For instance, no injuries. Let's be optimistic. And then you get the chance to describe the event so that the
Yes.
chatbot will reply, okay, I understand there is no injury. And now could you describe in your own words the kind of event that occurred?
Yes.
And then what does the chatbot do, produce to the user?
Yeah, like so let's say a user picks no injury. In that situation, like so for the no injury, there's a like predefined path. So in this predefined path, so basically what user has to do is like enter the accident description, some other data related to who is involving with this accident, and then the chatbot is going to ask another bunch of questions in order to get a bit more context, and then basically at the very end of the process, like so we report this thing, so we generated some extra like PDF, that kind of things. So these things need to send the relevant authorities. In addition to that, we send some accident preventive like recommendations for the end
Okay,
user. Yeah.
so the output of the chatbot are recommendations.
Yes, recommendations.
Okay, so once the classification and the risk are identified, you say, for instance, well, there were no injuries, but you should patch this hole in the ground because people
Yes.
are going to fall into it, or wear a helmet, please, something like that.
Yeah, exactly. Because in our database, like we have a map lead. If we know the high level accident category and then the description, so this is mapped with a particular set of recommendations. So we pull this recommendation and then send that thing to the user.
I understand. Okay,
Yeah.
thank you.
Thank you.
It's much more clear this way. Yes,
Okay.
beautiful interface, by the way.
Thank you. Thank you.
So if you have a question for Upul regarding his presentation, just raise your hand by using the raise hand tool in the upper right corner of the Teams application. I see that we have a question from Jian, so I'm going to ask him to ask his question.
Yeah, hi, Upos. Thank you very
Hi.
much for the presentation. I'm Jian Yunyi,
Thank you.
a professor at the University of Montreal, and I'm leading this initiative of CLIQ-ai. Thank you very much for the talk.
Thank you.
Just a few, not a few, just one or two questions about your talk. First thing, you have two classification tasks. So one is to determine the category of accident, and then the risk prediction. What's the difference between the two tasks?
Yeah, so it's kind of like identical. So like so basically the first one we identified because you know that we discussed this mapping. So mapping comes with two things like accident category and then accident description. So initially we thought like create two machine learning models to locate these two things using the accident description. That was like our first implementation. So then later we realized that we can combine these two things to one machine learning model, and that basically output both the accident accident category and the risk. So,
okay, I see.
yeah.
And also, I'm wondering, I'm not very familiar with the organization of accident report. I assume that there should be some hierarchy in the different events, right? So you have, as you showed on the screen, you have several large categories as input, and then I assume that you may refine the categories. Is that a hierarchy taken into account in your training process? So for the moment, you have 150 categories. If you try to organize in a hierarchy, then some related categories could be put together to train a higher level category. Have you thought about that, or is that done?
Yeah, I think I would say like this is a really good, the recommendation. So we didn't think about that way actually. So we thought this as like 150 individual categories, flat categories. So we didn't think like hierarchical approach. I'm happy regarding that input. So we need to think that as well. So that might be another avenue to think this question.
Yeah, I think that will be interesting to explore because in your context, you don't have a lot of data for the training, and by grouping related categories, you could get more data in a higher level category. And by the way, this is a typical situation that we try to deal with in CLIQ-ai. That is, a lot of real applications do not have a huge amount of training data. And as you showed here, we have limited amount of data and how we can apply the AI techniques to solve those problems. So that's very interesting, a good illustration of what should be done in practice. And sorry, you also talked about the data augmentation. Have you tested the impact of data augmentation in your system, or do you plan to do that in the future?
We did a sort of like a primitive testing related to the impact of the data augmentation. So we were able to reach maybe 3 to 2% accuracy improvement using this simple data augmentation. But as I mentioned, so we have another initiative, we are thinking some generative models to generate more data if possible in the future.
Mm-hmm. Thank you.
Thank you.
I will leave the others to ask questions.
Thank you. Thank you.
Well, if I have time, I can come back.
Okay.
Other questions. Thank you.
Thank you.
So if you have questions for Upul, don't be shy. Just click the raise hand tool in the application. I may have one question for you, Upul, and then on slide 22, you showed that you have a cascading system where a model follows another model, and there is some sort of redundancy here because you use the data twice, and once to predict the classification, and then use the result to predict the risk. Have you thought about using a multi-head deep learning system where you would be able to, with a single model, produce the two labels?
Actually, so we just started this initiative, combining these two things. That is a really good suggestion. So I really appreciate it. So we need to look at that as well. So yeah. So right now, we didn't think about it.
Yes,
Really appreciate your input.
because the architecture that you're proposing here may be very good, but it's a bit more unwieldy because you get two models that you have to train. If you train the first one, and the one that is after is dependent upon the behavior of the first one, so it's a bit more complex. So it may be interesting to use a multi-head system, a multi-head predictor to work with that. I just have another quick question. Could you describe where you found the data, the description of accidents? It's quite exotic data. I was wondering where it came from.
So it came from one of the customers. Actually, this is a customer data set. So this is not a real data, like because I can't expose the real data. So I created this accident description, which looks like the actual data. So unfortunately, can't expose that real data. So it's a custom asset at the moment.
I understand. Thank you so much for these precisions, Upul. Very kind of you.
Thank you.
Are there any questions from the audience?
Do we have a time?
About 4 minutes.
Okay. Okay, so I may have another one, which is about the description or modeling of accident categories. So in your process, I assume that you have your accident description and the category description somehow, and using BERT to try to determine the matching score. And based on that, you have your classification scores, right? I'm wondering what you use as the input to the category description. Do you have a text description, or do you want to train a category description based on the cases? How is that done?
Do you mean, I think, so this one, like risk categories?
Yeah, you have a category, so you have only a few words. Do you only use those a few words, or do you use additional information to describe?
Actually, this information, like, so we treat this as a, like a, as a label. And so we use a label binaries and then binaries this thing and use it.
Right. So I think in that case, the description of the category will be quite limited because you have a few words. So one possible idea is to look at the cases that you put in the category, and you can collect more information from the case descriptions. And maybe, for example, here you have step ladder. Related to that category, you will have different descriptions about the event, and in those descriptions, you may possibly find some more related information to the accident description. So if you describe a similar accident, maybe you can find additional information that can match. And this may be used to enhance the category description or category modeling.
Yeah, I agree. Yeah, thanks for the suggestion.
Yeah, good. Thank you.
Thank you.
So I'm going to thank our presenter, Upul Bandara from Airudi Inc. And I think that we're going to move on to our second presentation. Thank you, Upul.
Thank you.
So now Philippe Racine will present how AI will disrupt HR. So Philippe Racine is Stent CEO and senior partner of the group, but above all, he's a leader, and he's also a concept creator with a long list of successful IT companies, an international patent which is pending, and several innovations to his credit. He's interested in AI, the Internet of Things, fintech, data mining, and so on. So at V3 Stent AI, Philippe and his organizational skills guide his team, and off his employees support in the face of their complex challenges. So it's really a pleasure to welcome Philippe today, and I'm going to leave the floor to you, Philippe.
Okay, thanks everyone. All right, so my presentation might not be as technical as Upul, but I'm available for future discussions if needed. I wasn't sure of the format, so kind of decided to go with a higher level view of what we were doing and how basically HR would be disrupted by AI features. Quick understanding of the HR space. Of course, AI can be used in different ways, whether we're talking about machine learning, natural language processing, reinforcement learning, deep learning, pattern recognition, all of these different ways of enhancing how a recruiter will actually do his job, or an HR manager. Um, um, we've decided to use some of these components, not all of them. Of course, there are different strategies and different modules that can be added. One of our clients, a recruitment agency, asked us to simplify their sourcing process and to better qualify profiles, and allowing them to save on time, of course, and to do a better job. One of the reasons as well why we've decided to invest energy and of course we're paid for, is that many companies will invest in AI towards their recruitment process. So it's very interesting to know that billions will be invested in the near future in these type of tools. Of course, Stent AI would like to grab some of that market, and have done so by creating specific modules helping various companies in their biggest business pain, or actual business pain, which is the shortage of labor. One of the problems that was mentioned by many of our clients, basically, and mostly recruiting agency, is the time-consuming process of sourcing candidates, and therefore as well the impact was the quality of candidates versus the quantity of candidates. So when we've looked at their process, we've realized that many steps could be simplified by the use of AI. So this is where we actually focused on some of these important tasks that were done daily by recruiters, and we've tried to help them save hours of unnecessary time that the AI will allow them to save. Overall strategy for everyone was to find best potential candidates from various sources. And there are many sources, including LinkedIn, of course, which is, a source that everyone knows very well. But the objective was, how do we find candidates from various sources? And we try to go with quality versus quantity. How can we engage with these candidates? What is the best way, or how can AI help us decide if sending a LinkedIn message or an email, or using other social networks to engage with these candidates, and how AI would actually assist us on allowing us to, as I said, better interact with these prospects, candidates. And another module that made sense for many of these companies was, how can I use my employees part of this recruitment process? Why? Because my employees have a number of contacts within their level 1 network, and how can we use these networks of employees to engage with these candidates through the employee? So this is basically what we had to play with. So that was our sandbox. And this is how we actually created the full process and our technical stack. Our technical stack basically is comprised of the ability to read unstructured data. So unstructured data is basically a resume, a job description, any data that is not structured. Structured data, of course, is an Excel file, JSON file, or anything coming from LinkedIn or other sources that have structured data. So we push that data through our API. We send it to our knowledge graph, using a bunch of algorithm, we basically validate what makes sense to keep, to organize, to rank in terms of profiles. So once that content is understood, semantically analyzed, we are able to rank these profiles properly, organize them within the knowledge graph, then decide how we want to use these that data. So whether we want to automate campaigns, whether we want to integrate that data to the client's ATS or CRM. An ATS is the application tracking system, a CRM. These are the tools that most organizations have, whether we're talking about Salesforce, Zoho, HubSpot, Bullhorn, Cornerstone, etc. These are the tools that most companies will use in their recruiting process or in their lead acquisition process. So we basically integrate our knowledge graph to these tools. And thirdly, we are able to create segments. So we have a feature called segment builders based on how the content has been structured, organized. We're able basically to launch different campaigns. So let me show you basically how this is actually integrated within a specific tool and how it's used by an existing client. So first, of course, we all know that data is crucial. AI without data cannot work properly. So this is the issue that most companies have. How do I train my data if I've got little data? So what we do, we integrate what we call the multi-sources finder. We try to get as much data as possible. As I said, whether it's from LinkedIn, whether it's from your CRM, whether it's from your ATS or external database, GitHub, Rhetoric, LinkedIn, People's Data Lab, as I said, Bull on your ATS, we integrate these sources through our API, bring that content back to our knowledge graph, then we can properly do our job, which is allowing the client to import his job description. A job description is a resume of what I'm looking for. So the persona, if we can say, of ideal candidates. So we allow the client to either import a PDF, a Word document, what he would normally share on Indeed or any job board, or what he has available when he decides on hiring a new, for a new position within the business. Someone within that business has to clarify what they're looking for. Once this is clarified, this is imported within our platform, or it can be text. So I don't have that on a PDF form. I'm not, posting anything. So I would edit like I would write a story, what I'm looking for. I'm looking for someone with a lot of experience in agile. That person has at least a master degree, skills 1, 2, 3. So based on that, our tool will basically allow the import of the job description and the weight of specific criteria. For example, I'm looking for someone, but it has to be skill number 1, 2, 3. I have to be very, very high level. Although I'm looking for someone with a master, I'm mostly looking for someone with a lot of experience in Scrum Master, et cetera, et cetera. So the ability to actually configure the job description and weighting some specific categorized sections will better define the type of position that I'm or the type of candidates that I'm looking for. Once we have that, of course, we're using AI and what we call a candidate ranking system will consist of multiple modules ranging from unsupervised machine learning methods for keyword extraction to semantic matching using dense representations by leveraging state-of-the-art deep learning models that have been fine-tuned for semantic equivalence. So what we basically do, we'll actually analyze a job description, look for all the entities without the job description, and convert them into a digital format, so we can basically use NLP modules that are capable of categorizing profiles into different domain and seniority categories. So these modules have been developed with a combination of state-of-the-art deep learning, machine learning approaches, utilizing different variants of transformers, support vector machines, and other assemble methods to establish competitive baselines. So once we have that, basically a job description converted into, digital codes using BERT, the entities are understood by our AI tool, converted it into, as I said, a code, and compared to all the profiles that are also analyzed by our tool, transferred into a digital numeric profile, and then we match the job description with all the weight that I've configured with all of these profiles, allowing me to rank basically the best possible profiles within the list of thousands of profiles available from these various sources. Of course, if a profile does not have any data, I cannot do my job properly. But because we enhance every profile by looking at different sources, so if I don't find enough data within my, the resumes that I've accumulated within my ATS, I can look for complementary data set that I'll find in a public LinkedIn profile or in other external sources such as GitHub, etc. And it's by compiling as much information on a profile that I have available that I can compare best possible profiles with the job description, allowing me, as I said, to rank these profiles. Once I have that, what is interesting is that I can actually have a dashboard showing me all the candidates, where I found these candidates, from which sources, how many sources did I add to enhance that profile. I've got enough information to engage with that prospect. So whether I want to be using the email, whether I want to be using the employees, because I've also was able to link that profile with some of my employees. And based on that, of course, the tool will decide on what to be using in terms of tool to engage with this specific profile. So what I'll be doing, sorry, I'm just trying to get the my screen was just frozen for reasons I don't know. Here we go. So next step is how to generate the highest engagement ratio as possible. So what we've done is that we've trained neural network on closed or archived campaigns to predict the probability of engagement for each profile. So as we get from the client all the discussions that they had with in previous campaigns, I can almost predict who will engage with me and how to engage with that person, whether it's on LinkedIn, whether it's through an email, whether it's through a telephone call. I will actually be able to better organize and predict how we should engage with that specific profile. Of course, we're talking about machine learning. So as we move on and as we do more campaigns, we'll be able to better predict how to engage with these people. Another thing that we've created is the smart follow-ups replies. As someone will actually get a message from the sourcer, from the business, inviting them to consider a job position, their replies could be negative, could be positive, could be a mix of both. So what we've created is a way to automate the reply, at least to better understand the response of a candidate. So the model has been designed to detect the intent of a reply in the context of recruitment, of course, and generate an appropriate response accordingly. So the model was developed by leverage pre-trained BERT, weight, and fine-tuning them for this downstream task. this was really, really time consuming for a recruiter, for a sourcer to have, you know, the obligation of looking at perhaps 100 messages, not knowing what the candidate was telling them. You know, no, I'm not interested. Yes, I might be interested, but I'm looking for more information. Could you send me, you know, something else? Or where did you get my name, et cetera, et cetera. So based on that, preset of messages were organized, segmented within different categories, and sent to the candidate, saving tons of time to, of course, the candidate. When the reply was not clear enough and not understood enough properly, that message would go into the segment of have to take that manually. But messages that were very clear, yeah, sure, give me more information, or no, I'm not interested. Of course, these are very simple ways of reading or understanding a message. Well, these messages were organized, and an automated reply was sent to save time to the recruiter. So this is very, very interesting way of, as I said, saving time to someone using AI or using NLP to better understand, you know, discussions or interactions within a candidate and an employee or a recruiter. Last portion of the project was, how do I use my employees to have a bigger network of potential prospects. So we're looking at a simpler graph where what we need to be doing here is finding similarity degrees with all the level 1 contacts of an employee. But we have to do something else. We want to be making sure that it's the right employee that will actually be contacting that candidate, not 5 of my employees, not 10 of my employees, because someone can be in different network of my employees, but don't have the same similarity level with all of them. So what we've created is basically a way for Sophia to basically have her network analyzed by the tool, so that when Sophia wants to share content, she can do so using the tool and target you know, the right audience to share, for example, a job description. And in another network, for example, Tom's network, who had a couple of contacts, basically profiles within his network. For example, Tom, based on the job description, had 13 matches, but not all 13 matches were appropriate contacts to be contacted by Tom. Only 3 were actually had a very high level of similarity within Tom, because Tom went to the same university, because Tom, you know, worked with some of these profiles. Tom was chosen among different employees within the organization as the first one who would contact these profiles. If Tom was not interested in doing so, then we would jump into the second employee who had the biggest tie with some of these contacts. So this is basically what we're doing, is we're ranking candidates, then we're ranking employees the same way, so that based on their experience, education, location, title, skills, etc., best similarity degrees, or ranking best possible employees to interact with and engage with these future candidates. So this modules basically allows you to compute a proximity score for a set of candidates within a given network. So the method used uses different embeddings generated with the use of deep learning sentence transformers that are capable of producing contextual dense representations. The embeddings are used to produce local and global feature scores that are aggregated to compute the final score. So what we're seeing here is basically an example of how I can rank a candidate, but how I can also rank an employee who would be the best person to engage with a specific profile. So this is pretty much what we've been doing for the last 2 years, onboarding, of course, companies to test this model, and generating great results which are engaging further with candidates, which are very, very difficult to find in this time. And so any tools that can help these companies, such as what V3 Stent is doing, has allowed these organizations to better recruit and, most importantly, save money and time of their existing resources.
Thank you so much, Philippe. It's really impressive. I must say that it's really quite the machine you have there. I mean, you've touched on every type of NLP technology there. So graph networks, graph neural networks, you have transformers, you have clustering, name entity recognition,
and invested tons of money doing so. We've got about 10 full-time engineers / data scientists that are full-time on this and have been full-time on this for last, I would say, easily 2 years. 2 years ago, we were one of the first company to really get our hands into the BERT concept. 2 years ago, we knew about a few NLP programs. So BERT was slowly getting or emerging from different other algorithms. So I think we were happy to make, I think, a good choice in terms of that technology, and we've been focusing on just enhancing our knowledge within these different algorithms and different tools, and the result has been beneficial for our business.
That's very impressive, and you answered my question. I was about to ask you how many people for how much time have been working on this. So it's 10 persons for 2 years.
I would say that we've used easily more than a dozen of full-time people. We've got consultants as well working for us. We're working with external experts helping us in different steps of the implementation of these tools. As you know, I mean, it's not just the data scientists that are useful within an AI implementation. It's how to structure the database. It's how to compile and organize data properly, et cetera, et cetera. So it's the front end as well as the back end, because if the interface is not, clear enough for the end user, no one is going to use it. So I've realized that AI is something that can be structured and organized with way more than a data scientist or a set of data scientists. The front end has to understand how this will work. So we've trained many of our employees, little trainings that were actually offered for them to better understand, some AI components, and whether they don't have to go deep into the Python programming, at least they could understand and better visualize how all that was working and help us in areas that sometimes has nothing to do with AI. So front end, even the back end, the database, all of that was better organized because of these little trainings that we've done for all of the employees.
Great, thank you. Now I'm going to ask the audience if there are any questions. So just don't be shy. You can raise your hand whenever you have a question. Because I have some on my own. Just a quick question, Philippe. I'm not really familiar with all the tools in HR. What are Bullhorn and Rhetoric?
Bullhorn is an ATS. Let me just show you quickly. When I mentioned here in the technological stack, I've mentioned that we were able to read unstructured data and structured data. Bullhorn, as an example, has structured data. Bullhorn is an ATS. It's an application tracking system where you save a candidate within your platform, within your ATS, and that platform allows you to, invite the prospect to a Zoom call or a Teams call. You keep notes within your tracking system. You organize a flow of messages to be sent to that profile every 6 months or every year, you know, just to keep him informed. So an ATS is basically a collaboration tool such as Salesforce. You're familiar with Salesforce, of course, or HubSpot. So these ATS/CRM have structured data, and we're able to connect to these tools. So we are shared with a lot of data coming from the client, plus data that is coming from the external world, LinkedIn, other type of sources. So it's the combination of both that allows us to rank candidates more adequately.
Thank you. I see now that Jianyun has a question, so I'm going to leave the floor to him.
Yeah, good. Thank you, Philippe.
You muted yourself, Jianyun.
Oh, sorry. So it's okay. Thank you, Philippe, for the talk, and that's very interesting application. And I just would like to mention that yesterday I read an article about the application of AI in interview systems. This was done. It is done in ByteDance company, a very large company in China. Mm-hmm. And they are faced with the problem of a lot of interviews. Well, this is a company with 10,000 of employees, so a very big company. But mm-hmm. they also have about 1 million interviews every year. So every day there will be more than 3,000 interviews by different employees. Trying to organize that is very complex. So the HR, the head of HR is a technical guy, so he has an idea of building a system to track the interview, which is done in the company, trying to match the employees with the candidates, some kind of a similar goal mm-hmm. as talked about. But also try to rate the interviewers, by saying that this interviewer, this employee is good or is bad, and so on. So it is not only to rate the candidates, but also to rate the interviewers, so that in the system they have an overview of all the employees, how they perform during the interviews, and also try to organize the interviews to not repeat the same questions, because if you just let the employees to imagine the questions in the interviews, they will just repeat the same question several times during the process, 5 or 6 rounds interviews.
And interviews are done because we thought about this new module that actually was very smart. We had some doubts about a few things, but since we're able to add in face recognition, because I did not mention, but we also predict we're actually analyzed by reading by analyzing a LinkedIn profile. If the picture is available, we can also know the age and the sex of the profile. So that's something we also have. Of course, we're using a Microsoft preset of set of face recognition algorithm. So this was an easier project, of course, as we did not have to build anything. We're just using something that was existing. But in terms of interview, there's 2 things. You can basically analyze the face of the candidate while he's doing the interview and see signs of stress or unclarity towards a question. This is great. I think AI can be applied for that. But are you also recording, or is what you've read, are they also recording the interview and with NLP analyzing or converting the speech to text so that they understand what was said and what was answered?
No, I think this is not recorded. It's on-site interview by employees. So they, at the end of the interview, I guess they have to report the interview process by putting all the questions that they asked and mm-hmm. all what's the impression that they have during the interview. So this is a kind of information that they record into the system. I don't think that they use face recognition or any video analysis to analyze the process.
Okay, because when you said 3,000 or millions of interviews, if you could only go into a web address and a set of questions with a virtual sourcer or recruiter, so you would be asked, hi, can you explain why you want this job, etc. And based on your answer, I can actually rank you as a good profile or not based on what you actually answer on all of the questions, because that way I could actually rank you without having a physical person doing millions of interviews, because that's way too consuming in terms of time.
Yes, so that will be a good idea, but I think in that system it is not before the trying to find the candidates. They have already the candidates, so they try to organize the interview process.
Yeah, I see. Yeah, very good.
I have just one question about the trying to determine the requirement for a job. So you have a position in the company and you want to set up a set of requirements. And very often when you read the requirements, they overclaim very often the requirements by saying that, I need a PhD for a job of a programmer, or this typically occurs. So they require a lot of qualifications not necessary for the job, because in their mind, I would require more, and that would be better. So I'm just wondering how you could help to write a job description at the right level, because you have here some setting by saying that, this is required 100% and that is 50% and so on. And this is a way to deal with that problem. Some of the requirement is not a hard requirement, so I can tolerate that this is not obtained or owned by the candidate, but some hard requirement should be owned by the candidate. So that's a way to deal with that. So I'm just wondering if this process of job description can be done in an interactive way, by saying that the system will provide some feedback to the writer of the job requirement. So I may put a lot of requirement, and then the system may provide some feedback by saying that, for that profile that you require, I can find 5 candidates, and it may not be enough. And if you try to modify a little bit your requirement, then I will be able to find 100. And then the company will be able to see, which one I can be more relaxable.
Right. Yeah, we thought about that. Basically, one thing you've mentioned is not something we've added, but we've kind of done the same, or applied the same logic. Basically, if the job description is not clear enough, you just said it, for example, skills is very easy to analyze. I know a job title, very easy to analyze. Location, very easy to analyze and to understood. Soft skills, much more difficult. So we actually have started analyzing soft skills. Someone who would get along with other employees. So these are skills that might be important. So this is one of the things that we've started doing. So that's phase 2, analyzing soft skills as much as analyzing all the other technical skills, because the other ones are actually working very well. The ratio is very, but soft skills, I agree, it's too complicated still to fully understand what a soft skill is. And do you apply? Is it a soft skill? Is it a technical skill? Sometimes it's different. What we've done to allow a recruiter is that once he gets the dashboard, for example, with 200 profiles, all right, because his search and the weight he's applied allowed him to find 200 profiles. It's enough. If you only find 15 profiles, you can actually go back and look at the weight search criteria and modify that, and perhaps decrease the level of some of the weight. For example, the fact that I've added a JavaScript, very important, I'll reduce that. I'll put it less important. Therefore, I will actually find candidates that were not found on the first run that could match, but it's not exactly who I want, but at least I've got more candidates. Because the reality, if I don't have any candidates to contact, well, I'm stuck somewhere. So
Right.
what you've just said is something that we thought of. Basically, you will allow the sourcer or the recruiter to modify the weight criteria and reduce or modify so that we find more candidates, allowing him to decide that sometimes maybe this candidate is not the best one, but still a valuable candidate, and help him, work on specific skills that could be enhanced for this job, but are not crucial for this specific job.
Yeah, exactly that.
Yeah.
Very good. Good, thank you.
My pleasure.
I'll leave to the other questions.
Yes, thank you. Are there any other questions in the audience? Well, I may have a quick one. At Raleigh, Genune's and my laboratory at the University of Montreal, we've worked on matching candidates with LinkedIn profiles. And one of the issues was the fact that there are profiles that are very shy. So they have very, very limited information, maybe because they don't want to disclose that they're looking for a job to their employer. And since most of these approaches rely on the overlap between the criteria of job description and a user profile, when the user profile is very limited, what do you do? What do you think about this problem?
We do two things. We look for other sources that might have more information. For example, an IT developer will have a very shy profile on LinkedIn, but will actually show a lot of his experience on GitHub. So because we will see on GitHub that he has worked with, Java, has, a set of APIs available, open source module, whatever, this will give us skills that are not found within his LinkedIn profile. Second thing is that if there's not enough information, we'll actually interact with him and ask him for complimentary questions. So sort of a chatbot, but it's actually an interactive question saying, listen, Fabrizio, your profile seems interesting, but we're missing a few information for us to target you as a potential candidate for this job. Would you be kind enough to send us complementary information on your profile? So we'll know basically if he's interested or not at this point, but if he is, he will share more information. Therefore, we can actually include him in the final ranking. So we don't exclude any candidates, never. Candidates we don't have enough information on, we ask them questions. And you're right, we've run into this issue. When there's not enough data, it doesn't mean the profile isn't good. It simply means we don't have enough data. So ask him, and if he doesn't want to answer, it means he's not interested. So get him off your list. That's it.
Great. You've thought about everything. Yes, it's the human in the loop, and always the data, which is one of the main challenges of the consortium that Genune is leading right now.
Yeah.
So I think we're going to end with this, if it's okay with everyone. And we thank Philippe once again for his detailed presentation, and of course Upul as well. It was really interesting to dive into a new domain like human resources, and it was a pleasure to welcome them today. As always, a recording of the event will appear on our website, so it's always CLIQ-ai. You can look it up in Google, and you have a recording of all the previous meetups if you wish. So I'm going to thank everyone for attending this meetup. I hope you enjoyed the presentations. Stay tuned, and I look forward to seeing you all next time. Until then, have a nice day.
Thank you, everyone.
Thank you, everyone.
Thank you, Upul and Philippe.
Thank you. Bye.